everybody. So today we're doing the lesson in case you missed January 30th. It was a Friday. First instruction is to make sure that you finished putting this parent functions into your notebook. We had it on Wednesday the 28th when we had a sub. I put mine on the back side of a piece of paper because I'm worried that I'm going to run out of paper in my notebook, but it doesn't matter if you have it on the next blank page or the back of a page. Either way is good. Today our title is Module 7, Lesson 2, Quadratic Inverse Functions or Inverse Quadratic Functions. Our first problem is going to be, what if we have f of x equals the quantity 4x squared, right? Well, our first step to finding an inverse is to solve for x. And then right away, there are two different ways that you can do this that both will end up with the same answer and be equally correct. So one, you could go, okay, y equals the quantity 4x squared, and you could just, boom, go ahead and take the square root of both sides. So when we have a square and a square root, that leaves us with just what was squared, which in this case was the entire parentheses. Now be careful, because it might be tempting to go, oh, the square root of 4 is 2, but this is 4 squared. The square root of 4 squared is 4. So that's how we got 4x equals square root of y. From there, the x is not alone yet, so we have to move the 4. The 4 is multiplying times x, so we're going to divide to get rid of it. The fraction bar is a division sign, so we have 4 divided by 4 is 1. So we have 1x equals the square root of y over 4. Step 2 is to invert or trade our variables. So we'll go ahead and do that. I'm going to do the square root of x over y. My bad. The square root of x over 4 equals y. My brain was already writing the equals to part. And then we can put a box around that because that is our inverse function of f of x. I would like to comment that you can write that another way, so I want to make sure I show you in case it's ever on a multiple choice question written differently. But since we have 1 square root of x over 4, we could also write it as 1/4 square root of x equals y. Those are both the same thing. And then again, that would be our box. Someone in one of my classes wanted a little more clarity on that, so let me show you again. So if we have 3 over 4x, that can also be written as 3x over 4. So if we have 1 square root of x over 4, that is the same as 1/4 square root of x. All right, let's go ahead and add to this. Another way we could do this is we could do f of x equals 4x squared, quantity squared, so I'm just rewriting my problem. Make sure you have your parentheses around the 4x. We could distribute that squared to everything inside and get 4 squared x squared equals y. So that makes it y equals 16x squared. Still trying to get the x by itself, so I can divide both sides by 16. We get y over 16 equals x squared. So that tells me what x squared equals, but I need to know what x equals, so I'm going to take the square root of both sides. Notice I'm taking the square root of the top and the bottom of that fraction. So we get square root of y, and then the square root of 16 is 4, and that equals x. Check it out. Doesn't matter how you do it. At that step, they are both the same, and then you can bring them down into either of these when you change the variables. I would like to add our restriction on here, right? Our restriction or our limit that x has to be greater than or equal to 0 because we cannot have a negative at this point because the square root of a negative number would be imaginary and we're not going to be able to graph that. All right. Next example. So on this one, we had f of x equals x squared minus 6. This problem is more like the one we did 2 days ago, so if you have those notes, that'd be a good place to go. But we did this around the room on our own or with small groups, so pause, try it by yourselves first. Welcome back. First thing we're going to do is add 6 to both sides, so we get y plus 6 equals x squared. I have an x squared. I need to know what x equals, not x squared, so I'm going to take the square root of both sides, really making sure that my radical sign goes all the way past the 6, right? So then we get square root of y plus 6 equals x. Because when you have something squared and you're taking a square root, it's like those two things cancel each other out, and so we're left with just the x. Because if the square root of x squared would be x times x, so that answer will be x. So it's like the square and the square root are opposite operations. Okay? Now we inverse the variables, right? Inverse x and y. So we get the square root of x plus 6 equals y. Noting again that my radical sign goes beyond the 6. Okay? I don't know why I wrote the equals so high. Then we have spent a lot of time checking these, so let's go ahead and check this one. We're going to check by taking the function of x composed with the inverse function of x. I start by writing our original, which is y equals x squared minus 6. I draw a beautiful arrow to show what I'm going to put in. I'm going to substitute whatever I put in that box. So we're going to substitute x square root of x plus 6. So then when I write that out, I get y equals square root of x plus 6, all of that squared minus 6. And so again, when you have a squared and you have a square root, they cancel each other out. So we get x plus 6 minus 6, which is x plus 0, which is x. Right on. I would like to remind you that this one also was restricted to when x is greater than or equal to 0. That's a limit or a restriction. All right, turning the page. So that was for a quadratic. What if we had a cubic function, right? So let's do Module 7, Lesson 2, cubic inverse functions. And our example is going to be p of x equals x cubed plus 4. As always, we are solving for x. So to get the x alone, I need to move the 4. The 4 is adding, so I'm going to do the opposite, which is subtract. So we'll do minus 4 to both sides. I get, y minus 4 equals x cubed. So just like to get an x squared to be just x, we took the square root. To get an x to the third, we're going to take a root to the third, or a cube root. So we put the little 3 on that little shelf part, it's called the index, and we get the cube root of x cubed. And then on the other side, we'll get the cube root of y minus 4. Make sure your radical sign goes all the way to the end of the 4. The left side will stay the same, cube root of y minus 4, but the to the third power and the taking the cube root, it equals x. Then we need to invert, right? Trade our x and y. So we're going to get the cube root of x minus 4 equals y. And that is the part that will go into our box, because this equals the inverse of p of x. Let's talk a little bit about the domain. The domain here is going to be all real numbers, because a cube root does not have the same problems as a square root does with having negative numbers under the radical sign, right? So domain is all real numbers because we can have a negative under the cube root sign. And let's show an example of that, right? If we have the cube root of negative 8, well, that would be the cube root of negative 2 times negative 2 times negative 2. So that equals negative 2. It's not an imaginary number, so it's fine. Totally able to use that. Okay? The next problem we did in small groups around the room. So after you've written it down, go see how far you can get. So we have the function of x equals 1/3 x to the third minus 9. Good luck. If you're back because you are frustrated or stuck, then try it if I write it like this. F of x equals x to the third over 3 minus 9. And see if that's any better. It is the exact same problem. All right, welcome back. So let's go. So we've got minus 9. We'll do plus 9 to both sides. So we get y plus 9 equals 1/3 x cubed. To get rid of this 1/3, I'm going to multiply by the reciprocal, which would be 3 over 1. I do that because then it's beautiful. The 3's cancel. I'm left with x to the third. If you wanted to take the cube root already, you cannot, because the 1/3 is not being cubed. So, I mean, you could, but it would get messy. All right? And so that will equal, what did I do? I multiplied by 3, so I have to multiply this side by 3 also. Then let's go ahead and distribute that so that we get 3y plus 27 equals x cubed. From there, I'm going to take the cube root of each side. And so we get the cube root of 3y plus 27 equals x. Because again, the cube on the 3 and the cube root on the taking like the square root type of idea, they're going to cancel and leave me with just the x. That is as far as we can go, and I'm going to talk about at the very, very end why we cannot separate this and do the cube root of 27, which would be lovely because it's 3, but it doesn't work because it's still connected to the y, so you can't do it yet. All right, so then let's invert. So we've got the cube root of 3x plus 27 equals y. And I would mark this wrong. If you don't take your radical sign all the way past the 7, you can expect to get it marked wrong. You've got to be really careful. That's under the whole thing. And then this is our answer because that is the inverse function of x. All right. And then you can do the checking and plug it in, all of that. That would be nice. Your homework for tonight is page 101 and 102 in our workbooks. I did post it in Google Classroom because obviously if you weren't here, you didn't grab your workbook page. So that is in Google Classroom for you. You can just do it on regular paper if you cannot print. All right. That was it for today. However, if you want to know why this won't work or how to check if it works or not, I'm going to show that now. So everybody else can end. So if I were fighting with myself over, hey, can I take the cube root of 3x plus 27 and split it up to be like the cube root of 3x plus the cube root of 27? Spoiler alert, you cannot. But if I were not sure, this is a way I would check it, is I would do the problem both ways. I would choose a number and be like, okay, so let's pretend x equals, and then you could choose any number like 1, but I'm going to choose 9 so that I know that this is going to give me a perfect cube. So we're going to pretend that x is 9, and we're going to solve both ways. If both ways give us the exact same answer, then we can split them. But if we get different answers, then we cannot split them. So let's go. So 3 times 9, taking the cube root, that'll be 27, right? So the cube root of 27 is 3 because 3 times 3 times 3 makes 27. So the answer is 3 plus, this is also the cube root of 27, so that will also be 3. So it'd be 6. All right, so the answer, if we do it underneath and x happens to be 9, then it would equal 6. Now let's try it here. So if we have the cube root of 3 times 9 plus 27, that's going to be the cube root of 27 plus 27. That's going to be the cube root of 54. And then when I asked Siri earlier what the cube root of 54 was, I'm pretty sure he said that it would equal 3.66 something, I'm not sure. But it went on for a while. So 3.6 something, something, something. Well, the whole number 6 and the decimal 3.66 are not equal. So these two different ways of writing it are not the same. So that tells me that I have to keep it all under one radical, and I cannot simplify further. All right? Have a great day. Talk to you guys later.